With solving today, we are going to be using what's called the zero factor property. So we know that if we have a quadratic, it's something ax squared plus bx plus c, right? We've talked about that in terms of the graph. If we are solving these, we want it to be equal to 0. So if we have a quadratic equation, ax squared plus bx plus c equals to 0, then the first thing we are going to check to see in terms of solving this is if we can use the zero factor property. And so that tells us that if we can factor it, when you have a multiplication problem, the only way you get 0 for an answer is if you multiply by what? 0. When I'm multiplying two numbers, we only get 0 if one of the numbers is 0. So if we can get our quadratic equal to 0 and then factor it, we can use this property that the only way you have two things multiplied equals 0, one of them has to equal 0. So let's solve the problem. If I ask you to solve the equation, x squared equals 12 minus x. We first need to rewrite it so it's written like in the standard quadratic form, so equal to 0. We want our squared term to be positive because we're trying to factor, and when you're factoring, it's best if that x squared is positive. So what I'm going to do is add over my x, subtract over my 12. So that we have it equal to 0. All right, and then we reviewed factoring at the beginning of the semester, so we should all know how to factor this. What multiplies to a negative 12 and adds to a positive 1? Factors into x plus 4, x minus 3. So if we set those equal to 0, the only way to get 0 in a multiplication problem is if one of those things is 0. Solve. So if we subtract our 4, we get x equals negative 4. If we add over this 3, x is positive 3. Can we check our answers on these? Yeah, just plug them in. Negative 4 squared is 16. 12 minus negative 4 is 16. 3 squared is 9, 12 minus 3 is 9. So we can see they both work when we plug them back in. Right, so it's still quadratic and it's already equal to 0, but we don't have a c term. So what would I do here?
Take out the.
Yeah, we got an x. And that leaves us with x times x minus 9 equals 0. So that means one of these things has to equal 0. Either x equals 0 or x minus 9 equals 0. Add over 9. So we get 0 and 9. I don't care if you want to list it, if you want to write it in a solution set, if you just want to box in your answers. I'm okay with any of these ways of writing your answers as long as I can identify them. Okay, so 0 and 9 are the solutions there. Sometimes we might get the same answer multiple times. So I might get 2 and 2 for an answer. That is called a multiplicity. So multiplicity is a repeated solution. We're going to use that term a lot in the coming section. I want you guys to solve C for me. So first we check it's already equal to 0. So then we're set up to factor and solve this. So x squared breaks into x. Multiply to positive 9, add to negative 6 is negative 3 and negative 3. Set those equal to 0 and you get 3 both times. There's different ways of writing this. So what this means is 3 is the only solution. We just got it twice. So I know some of you when I was walking around just put 3. Some of you listed 3 2 times. A lot of times I'm going to say 0, find the solution in multiplicities. And so we could write 3m2. That means 3 showed up 2 times. It was a repeated solution. It had a multiplicity of 2. In terms of the solution, it just means 3 is the only number that works. When we draw graphs, that multiplicity is going to change our graph a little bit. So we don't want to just ignore it for now. We want to start getting in the habit of recognizing that, because as we get into graphing polynomials, that multiplicity is going to be very important for our graphs. So don't just ignore it. 3 is the only solution. It just showed up twice. All right, this one, if I want to solve it, what would I have to do first?
Subtract over 12.
I'm going to go ahead and put it in decreasing order, so minus 12x plus 9. Okay, do you remember how we solved these? We always look for a greatest common factor. Is there one between 4, 12, and 9? No, so we can't do greatest common factor. So instead, we do slip and slide. This is x squared minus 12x plus 36. Okay, what multiplies to 36 and adds to negative 12? To divide our 4 back. So that's 3 halves, so we get 2x minus 3 and 2x minus 3. So again, we're only going to get one solution here, but it works twice. So our actual solution is 3 halves. If I ask for the multiplicity, it's a multiplicity of 2. Every quadratic has how many answers? How many answers have we gotten on it? 2. Either we get 2 different numbers or I get the same number twice, but we always get 2 answers out. Any questions there? Let's look at a slightly different one. What if I asked you to solve x squared equals 5? It's a quadratic, but you'll notice I don't have the x term in this one. So we could subtract over the 5 and then try to factor. We could also do what if you just want to get x by itself?
Square both sides.
Not square, but
Or square root.
square root. So this is called square root method. If you just have the x on one side, we can add a square root. If you add a square root into the problem, what do you have to put with it? Right. Because we know it's quadratic, I should get 2 solutions. So this one, my answers are positive square root of 5 and negative square root of 5. Those are the 2 different solutions we get. Alright, if I'm looking at this one, what would we do? Two options. Give me one option.
Yep. 3.
Yeah, we could multiply it all out. If I want to square the x minus 2, what would I have to do to square that? We'd have to write it twice in FOIL. Get that, then distribute the 3. Then do what? Subtract over the 48 and refactor it. Will that work? Absolutely. Is there any other option? Okay, let's do that then. So, by FOIL, that gives me x squared minus 2x and minus 2x is minus 4x. Negative 2 and negative 2 is positive 4. Distribute the 3. Subtract over my 48. I need to do something before I do slip and slide here. What should I do? Yeah, greatest common factor. What can I take out of all these? Okay. What multiplies to negative 12 and adds to negative 4? Okay, this time I have 3 things multiplied. So if I set all of these equal to 0, does 3 ever equal 0? No, so that doesn't give me anything. What makes x minus 6 equal 0? Add over to 6 and we get 6, and x plus 2 equals 0. Subtract our 2, we get negative 2. So we get negative 2 and 6 for our answers. The 3 out in front doesn't change anything. Alright, this works. We got our answer. There was a faster way.
Divide the 48 by 3 and then make it square root it, I guess.
You guys want to look at the other option for solving this? Do you care if I erase what I have up here? So, I don't care how you solve these, as long as you can. So if that way is what you recognize, that's no problem. We got the answer. The other thing we could see is that in this, I only have x in one spot. So we could get x by itself. To do that, you have to divide by 3. So that means x minus 2 squared equals 16. How do you get rid of a square? And when we add a square root, we always do plus and minus. So that means x minus 2 equals plus and minus. The square root of 16 is 4. Then if I want to get x by itself, we add over the 2. So we get 2 plus or minus 4. So think about what that means. We have 2 plus 4 and 2 minus 4. 2 plus 4 is 6. 2 minus 4, negative 2. So we get the exact same answers, 2 different strategies. Either one works. I want you guys to try a couple. So you can use whatever strategy you want. Solve those 2 problems. So first one, you can either write twice in FOIL, subtract over your 4 and solve, or most of you did just do the square root. Plus and minus, so we get x minus 1 equals plus or minus. The square root of 4 is 2. We add our 1 over, we have 1 plus or minus 2. So 1 plus 2 is 3, 1 minus 2 is negative 1. H, if I want to get rid of a square, we have to square root. A couple of you forgot, when we do square root, it's plus and minus. If this is a negative 49, what's the square root of negative 49? 7i, so don't forget your i's there. We can have imaginary. So quadratic has two solutions. They could be real, they could be imaginary. Let's look at this one. Let's say I gave you 2x plus 3 squared equals negative 8. What would you do first?
Square root of
So that gives me a 2x plus 3 equals, we'd have to have a plus and minus. How would I break down the square root of negative 8?
I.
8 can break into 4 and 2. Square root of 4 is 2. We don't know the square root of 2. Because it was a negative, we also have an I. So plus or minus 2i radical 2. Then what would we have to do to get x by itself? 2x equals negative 3 plus and minus 2i radical 2. Final step, divide by 2. If it weren't imaginary, you could just write it as a big fraction. But remember we talked about with i's, we always write it in standard form, a plus bi. So we just separated it and put each thing over 2. So we would have negative 3 over 2 plus or minus, and then we do this one. 2i radical 2 divided by 2. What happens to those 2's? So we get negative 3 halves plus and minus I radical 2. Any questions on those? Final question of the day. For quadratic, ax squared plus bx plus c. Find a, b, and c if negative 5 and 3 are zeros. What am I asking you to do? Well, working backwards, I gave you the solution. I'm essentially asking you to find the original quadratic. So if negative 5 is a 0 or a solution, what had to be in my parentheses? If negative 5 made it equal 0, what was in here? X plus 5. Do you agree? If 3 is a 0, what had to be in my factor? I'm trying to find a, b, and c in the original quadratic, so now we just need to multiply this out. So if we FOIL, we get x squared minus 3x plus 5x minus 15, or x squared plus 2x minus 15. So what is my original a value? 1. What is the original b value? 2. And what was c? Negative 15. So we can work backwards and figure out what the quadratic was if we know our solutions. Alright, the assignment today is going to be Math Excel. What I want you to do before you put your notes away, I'm going to put something up here that I'm not going to talk about yet, but it's where we start tomorrow, and I just want you to copy that down in your notes. Okay, so the next slide, copy it down in your notes. Once you have it written down, you can start the Math Excel. That way it just saves us a little time tomorrow because today is a bit shorter. So, write this down. Completing the square. These are the steps I'm going to reference tomorrow. Once you get those written down, we're not doing any of these today. We'll start there tomorrow. Then you can start your